Introduction to Trigonometry, my favorite part of math. We're going to start with incredibly useful ratios, and as you can see we have right triangle ABC. For number 1, we need to name the side of the triangle opposite angle A in two different ways. So here is angle A, and the side opposite is BC. Or CB. We could also label it, since it's opposite capital letter A, we can label it with a lowercase letter a, and even though it asked us to name the side in two different ways, there's actually three different ways. So you can label sides of triangles lowercase letters that are opposite the capital letters. So moving on to number 2, name the side of the triangle opposite angle B in two different ways. So we're going to do it in three different ways. Here's angle B. So opposite that is side AC. So we can label that with a lowercase letter b, or we can designate it as side AC or side CA. And number 3, name the side of the triangle opposite angle C in two different ways. Okay, so opposite angle C, the right angle, which is the largest angle in a right triangle, is the hypotenuse. So we can label that as side AB, side BA, or simply lowercase c. When working with an acute angle within a right triangle, we identify the sides of the triangle based on its relationship to that marked angle. So the side across from the right angle is noted as the hypotenuse. We always locate that first when working with right triangles. It's the longest side, which is always across from the largest angle, the right angle. And the side that's across from the marked angle. So there's two acute angles of a right triangle. We have angles A and B, and since they've designated angle B, we're going to look across from that angle and label that as the opposite side. And then we have the side that's left, that's next to the angle, that is not the hypotenuse. So we label that as the adjacent side, ADJ. You're going to have to recognize that. You're going to have to recognize the angle that's in question, and you're going to have to label the sides so that you can set up the relationship that the sides have to the angles. So here we're going to practice doing that. So always across from the right angle is the hypotenuse. I'm going to label that first. Now I'm going to look at the angles that are in question. So the first one to the left here, QPR, we're talking about angle R. So the side that's opposite that angle is QP. And then the only one that's left is the adjacent angle. Okay, now looking at triangle or right triangle FDE, across from angle F is DE, so I'm going to label that as the opposite side, and the only one that's left is the one that's next to it. That's not the hypotenuse. We're going to label that as the adjacent side. The trigonometric ratios are functions of an angle commonly represented with the Greek letter theta. Theta is a variable, just like we have in our alphabet with math. Trigonometry likes to use theta to represent the angles. They relate the angles of a triangle to the lengths of its sides. The three basic trig ratios are called sine, cosine, and tangent, and they have the following ratios. So we begin with sine of theta has the relationship opposite over hypotenuse. Cosine of theta has adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So based on those relationships, it's the function of the angle is equal to the ratio of the sides. And we start off with the sine of angle A, which is also represented by theta. We're going to start with the opposite side of BC. So we're going to put BC in for the opposite over the hypotenuse of AB. We don't have to get too crazy with putting these segments above it. Okay, cosine of angle A has the relationship adjacent over hypotenuse, so the adjacent side is labeled as AC over hypotenuse AB. And the tangent of the angle is the opposite side, BC, over the adjacent side, AC. So what's going to happen later on is that we're going to have measurement put in for the lengths of the opposite, adjacent, and hypotenuse, and we're going to be able to solve problems. So here we go. Sine of A we know is opposite over hypotenuse, so the opposite side to angle A is 12, and the hypotenuse is across from the right angle over 13. Cosine is adjacent, so that's 5 over the hypotenuse of 13. Tangent is opposite, 12 over adjacent, 5. Now for angle B. It's opposite, 5 over the hypotenuse of 13. Cosine is adjacent, 12 over hypotenuse of 13. And tangent is opposite, 5 over adjacent, 12. So using the triangle pictured below, identify the following trig ratios. So I'm going to start with labeling the hypotenuse. That never changes. The opposite and the adjacent sides do, based on the angle that's in question. So the first one, sine of A, we're talking about angle A first. That's this angle here. Sine is opposite, which is 4 over the hypotenuse, 5. So it's 4 over 5. Cosine is adjacent to angle A, that's 3 over the hypotenuse of 5. And tangent is opposite, 4 over adjacent thirds. Moving on to angle B. That's opposite to angle B is 3 over the hypotenuse of 5. Cosine of B is adjacent over hypotenuse of 5. And tangent is opposite, 3 over adjacent, 4. Okay, so we need to find sine of D, set up the ratio of the sides. So here's the angle D, and sine is opposite, which is radical 3, over the hypotenuse of 2. Okay, so opposite the right angle is always the hypotenuse, so we can label that. Cosine of D is adjacent, so that's 1 over the hypotenuse of 2, and tangent is opposite, radical 3 over the adjacent 1. So now we're switching the angle to E. So sine is opposite, which is 1 over the hypotenuse of 2. Cosine of E is adjacent, which is radical 3 over the hypotenuse of 2. And tangent of E is opposite, 1 over the adjacent side of radical 3. Notice that the sine of D has the same value as the cosine of E, and the same goes for cosine D and sine of E. That's because these are cofunctions. And what cofunctions do is that, as you can see, angles E and D have a sum equal to 90 degrees. So one of the basic properties that we learned way back in the early fall was that the sum of the two acute angles of a right triangle are complementary. So E and D are complements of one another, and as you can see that the values of the complement in terms of sine and cosine will have the same values. So we call these cofunctions. So the sine of one acute angle of a right triangle is equal to the cosine of its complement.